Good morning, madam. Myself, I am M. Paul Reddy, studying in SRIT Engineering College, 2nd CSM. My roll number is 234G1A33C0. Now I am going to explain about binomial theorem. Let us discuss what is it. Now, binomial theorem. The binomial theorem is the method of expanding an expression that has been raised to any finite power. A binomial theorem is a powerful tool of expansion which has applications in algebra, probability, etc. It may use in algebras and also probabilities by expanding its powers. The binomial theorem is a fundamental concept in algebra that describes the expansion of a binomial expression raised to the positive integer power. Actually, in binomial theorem, the power element should be in positive. The binomial theorem is a mathematical statement that describes the expansion of a binomial expression raised to a positive integer power. Now, binomial expression. A binomial expression is an algebraic expression that contains two dissimilar terms. Example, a plus b or a cube plus b cube, etc. It may have two dissimilar terms in binomial expression. NCR is equal to, actually the formula for NCR it may uses in binomial expression. It plays the key role in binomial expression. NCR is equal to n factorial by r factorial into n minus into r factorial. The binomial theorem is also known as a binomial expression, which gives the formula for the expansion of the exponential power of a binomial expression. Binomial expansion of x plus y whole power n by using the binomial theorem is as follows. We can see here x plus y whole power n formula. X plus y whole power n is equal to n into x power n into y power 0 plus nc1 into x power n minus 1 into y power 1 plus nc2 into x power n minus 2 into y power 2 plus and so on plus n minus 1 into x power 1 into a y minus y power n minus 1 plus ncn into x power 0 into y power n. Here we can observe in the initial state nc naught, here the x component x power is n, and while going to the right hand side the power of x is decreased like n minus 1, n minus 2 and so on, n minus n that is equal to 0 like that, and the y term power is increasing from LHS to RHS. Here we can observe initially nc naught x power n into y power 0, while moving to the right side the power of the y is increased by 1. Now the key components of binomial theorem. Binomial expression of a plus b. Actually the binomial expression is a plus b. Power is n or positive integer. It may be any positive integer. Must and should be positive integer in power. Binomial coefficient. N chooses k. The coefficient of binomial is, it may chooses from n to k. Now summation. Sigma represent the sum of terms. Now the special cases. Pascal's triangle, binomial distributions, multinomial theorem, extension to more than two terms. These are the special cases which are used in the binomial theorem. Now the applications. The applications of the binomial theorem is algebra and combinatorics, probability theory, calculus, computer science. These are the uses. These are the components of uses where the algebra is used. Actually, in algebras, we use in mathematical, and calculus also we use, probability theory also, and computer science also. Proofs. The mathematical induction, combinatorial proof, and geometric proofs. These are the proofs for the binomial theorems. Now our question is expand 2a plus 5b whole power 6 using binomial theorem. Actually, however, the general formula of x plus y whole power n formula is there, no? Like that only we need to expand. It means here we can observe, we can decide as 2a as the x term and 5b as the y term. Here 2 and 5 are the numbers, so a plus a it may place the coefficient values, and n value is equal to 6. Then we can expand 2a plus 5b whole power 6 is equal to 6c naught 2a whole power 6 5b whole power 0 plus 6c1 2a power 5 5b power 1 plus 6c2 2a power 4 5b power 2 plus 6c3 2a power 3 5b power 3 plus 6c4 2a power 2 and 5b power 4 plus 6c5 2a power 1 5b power 5 plus 6c6 2a whole power 0 5b power 6. Here we are increasing the power term of the 2a is 6, and initially increased to 6, and then we can decrease from 6 to 0. Now the power term of the 5b is initially 0 state, and we can increase it from 0 to 6 state one by one. Now the 2a plus 5b whole power 6 is equal to 64a power 6 plus 30 into 32 into a power 5 into b plus 15 into 16 into 25 into a power 4 into b square plus 160 into 125 into a cube b cube plus 60 into 625 into a square b power 4 plus 12 into 3125 a b power 5 plus 15625 into b power 6. In the above case, we discuss 6c, c1, 6c2, 6c3 like that, no? Then we can calculate these values. We may get 64 a power 6 and plus 30 into 32 a power 5b, like that we may get the terms. Now then we can generalize that both terms. Then 64 a power 6 plus 960 a power 5b plus 6000 a power 4 b square plus 20,000 a power cube b cube plus 37,500 a square b power 4 plus 37,500 a b power 5 plus 15,625 b power 6. Here are the components we may generalize. Now, final conclusion of this binomial theorem is the binomial theorem is a cornerstone of algebra, offering insight into the structure of binomial expression. Its wide-ranging applications and extension make it as an independential tool for mathematics, science, and engineering. Future further directions, generalization to non-integral components, multinomial theorem extensions, applications in emerging fields, example data science, machine learning. Thank you for giving this wonderful opportunity to say about binomial theorem.